Okay, so this worksheet, you can find, it's on slide 40 something, 43 or 47, something like that. I can't remember. There's a link to this page, 40, slide 40 something. Okay. So we're going to talk here just briefly about the relation to these other pages.
Oh, whoa. Whoa.
All right. The first thing we're going to do today sort of relates to the worksheet. We'll get to that probably tomorrow. We're going to here what time today? 37. Yeah. All right. Here we look at these types of symbols, right? There's a slide presentation, right? Here's what we're going to be able to do with these. If you have a periodic table in front of you, that'd be great. So every day when you come in, you need to calculate the periodic table, right? So the periodic table, if you look at it, it'll give us some information. Find argon on there on the right hand side. Gold is AU, this is AR. Silver is AG. So far right hand side, we're 18, okay? So what does number 18 tell me about protons, neutrons, and electrons? What we're trying to do here, this is a great test question, is figure out how many protons, neutrons, and electrons are in argon 36. So how many protons are in argon 36?
Y'all see it?
Right.
So I'm kidding if I work.
What number is it on the periodic table? 18. That's the atomic number, right? That's the number of protons, right? So the number that it is on the periodic table is the number of protons, right? So each of these three atoms that we're symbolizing here have 18 protons. Am I good with that? It's just the number off the periodic table. Okay, how about neutrons? How are we gonna figure that out? What's that number right there? Yeah. So, what does it represent? Mass number, which is the sum of protons and neutrons. So if it's got 36 protons and neutrons, 18 of them are protons. How many of them are neutrons? 18. What are written in 2? Do to get that? Subtract, right? So this atom has 18 neutrons. How many does this one have? 20. How about this one? 22. Okay. Am I with me? All right. So protons, periodic table. Every argon atom has the same number of protons. If it had 17, it'd be chlorine. If it had 19, it'd be potassium. Okay. So everyone has 18, but these three different atoms have different numbers of neutrons. that makes these three atoms be what? Starts with an I. Yes. Isotope. Okay, these are isotopes. These are the three isotopes of argon. Okay, you got 36, 38, and 40. They all have 18 protons, but they have different numbers of neutrons. All right, there's nothing written in the top right-hand corner, so that implies that this has a neutral charge. So how many electrons would this one have? Also 18. How about this one? 18. It's got a match here, right? If it's neutral, these two are the same. So this is also 18. So if you're given a symbol with a mass number and a periodic table, you can determine how many protons, neutrons, and electrons are in that atom. Okay. All right, let's do the next one. How many protons are in an E carbon atom? Not carbon, sorry, copper. Wow. 29. I agree with that. Okay. 29. So this is number 29. Table. Okay. How many neutrons are in copper 63? 4. Okay. How about copper 65? 6. Okay. Very good with that number? Subtraction, right? Total minus part, equal to the other part. How many electrons in a neutral copper atom? And it doesn't matter which isotope it is. It's neutral, there's nothing written right here. These two numbers have to match. Yep. Those are the three most common by far. There might be another one. Okay. Last example. Real quick, hang on a second. So, how many protons in a calcium atom? 20. Okay. How many neutrons in calcium 40? All right, now we've got a charge up here, right? So how many electrons are in that atom of calcium? 18. Okay. All right, good. So this is an ion, right? Okay. All right, phosphorus 31 with a 3 negative charge. That's how many protons? 15. How many electrons? 16. How many electrons? 18. 3 minus, it has 3 more negatives than it has positives, right? Let's see how that works. All right, tomorrow we're going to talk about weighted averages and work these problems right here. Thank you.